Okay, so this time I'm going to continue on with some simpler instructions. I'm going to start with some string-based instructions like MOVS, compass, things like that. And if we look at these ones here, we can see that they're all zero operand. Even though this notation here suggests that they have multiple operands, they're actually just, for example, MOVSB, W, D, and Q. And they're all zero operands, so it's just this single opcode for these ones with the rex bytes with the W bit set for the 64-bit version. The thing that I'll be doing though is that I'll be using only the MOVS mnemonic in my code, and the same goes for the other ones. So instead of compare SB, compare SW, stuff like that, I'll just use compare S and then match on the width, for example. And one of the reasons for that is because, for example, this here, MOVSD, is actually already a mnemonic for a different instruction. So I could overload this and just have MOVSD also match on the correct width with no operands, and in that case I could output this, but I'm actually going to ignore all of these suffixed mnemonics here in favor of just using MOVS and matching on the width. I think it's just less confusing that way. So starting with the string instructions then, if we just go to the assembly tests, we'll do, for example, MOVSB. So I'll use the suffix mnemonics in NASM here to do the tests, but in my code I'll get rid of the size suffix. And then each of these has, so we've got W for word, D for double word, and Q for quad word. And so these ones are A4 and A5, so I'll just make a note of A4 here. Then I'll move on to, let's say, compare string, just because that's one that I've mentioned. So that is this one here. So again, this is the same thing, it's just that the opcode has changed. This one is A6 for the byte version and A7 for the other sizes. So I'll just make a note of A6 and change these to compare. Another one to do would be load. So let's have a look for load. Here's load string, LODS. So this one is AC and then AD. So we'll just make a note of AC here. Then we have the next one will be, let's see, we'll do scan string here. So we've got SCA, and that's starting with AE. And then the other one is store, which is STO. So down here is store, and that is AA. So let's just regenerate this listing. That all seems okay. And then we can just take this into the encoder tests. We'll just put it at the top here. So we'll just do, have a look for all of these, take these, we'll actually add these as mnemonic consts first. So let's just get rid of these suffix letters for the size. Uppercase, we'll add op, and then take them over to the encoder. Let's put them above opmov maybe. And for each of these, we'll just give them some empty form tables. Okay. So now we can just take these ones and add some tests for them. Get rid of that suffix. So these are just going to use the width to do the matching. So we'll have bytes, word, D word, Q word. And then all of these have zero operands, so these are all NA. So I just need to change this to word, D word, and Q word. And make it the same for all of these ones. Okay, so let's just copy this stuff out. And we'll get rid of these comments. Get rid of these ones down here as well, actually. Okay. Okay, so let's just put these up here. So these are the opcodes, basically. So we'll need to do a couple of matches for each one. One of them is going to match on the width of bytes because the byte has a separate opcode. This is opn ZO for 0 operands, and then the opcode for this one is A4. Then we just make a copy of this, do word, D word, and Q word. And this just goes up, it increments by 1 for each of these. So this is A5 for the other sizes. So we'll just copy this into all of them. And then we'll just take these opcodes for the bytes versions. Bring this down here. So this one is going to increment by 1 for 7. This one's going to go to D. This one to F, and then this one to B. Okay, so that's string instructions done. I think next that I'll do a couple of sort of atomic related instructions. So for example, compare exchange, which is this one here is what I'll do. So compare exchange here is just MR op encoding. So let's just go to the assembly test. So we've got compare exchange, and we'll do, for example, we need one for byte, word, D word, and Q word. So we'll start with, let's say, CLDL or something. And then this first one can potentially be memory, so we'll make this RCX. And then we'll just do one for each size. So we'll do word, D word, and Q word. And while we're here, I suppose I may as well just make a note of this. This is the same thing where it's the same encoding, but the opcode is just counting up by 1 in this case. So I'll just make a note of that here. And these are MR encoding. The other instruction I wanted to do was XADD. So this is just more of the same, but it's starting with C0 for the bytes encoding. So this one is C0, and then instead of compare exchange, we've got XADD instead. So let's just take these over to the encoder test. Okay, so we'll put these below here. Okay. Right, let's just do these ones first. So we'll do this uppercase with op before it. Then we've got bytes, but these are changing every 2 down. So this is now word, D word, and Q word. Then we've got CX and DX, and then NA, NA. But then, of course, these ones with the square brackets need to be memory access instead. And then the one down here is the same thing, but it's for XADD instead. So we'll change this to XADD. We'll get rid of all of these lines here. Take these notes out. Let's remove these notes from here as well. Let's go to the encoder and add, well, we've got exchange, for example. So maybe we'll just add it down here. So here we need op compare exchange, and we need XADD. So let's go add some empty form tables for these. Okay, so let's regenerate the NASM listing and try a test. Okay, so we basically want to match on width of bytes. Then we've got op_n here of op_n mr. The op_1 can be register or memory, and op_2 can be register. Then this one has the secondary opcode map. So the map is 0f, and the opcode is B0. Then for the other sizes, we've got B1. Okay, that looks, I think, okay here. And then for XADD, this is now, instead of B, it's going to be C. Got a syntax error. Opcode is also incorrectly spelt. Opcode. Okay, so those are a couple of atomic related instructions. Next, I think maybe I think I was going to do memory ordering, so I think that would be LFENCE, SFENCE, and MFENCE. So yeah, let's start with LFENCE. So we've got LFENCE here. Now this one's a little bit different because it has no mandatory prefix here. It's got the secondary opcode map, then the opcode itself. But then here, this is actually a fixed ModRM, or technically this one is actually a ModRM where it can be the 8 here can be anything between 8 and F, but the first digit must be E. So it describes it down here. It says specification of the instructions opcode above indicates a ModRM byte of E8. For this instruction, the processor ignores the RM field of the ModRM byte, thus LFENCE is encoded by any opcode of the form 0F AE E something, where the something is in the range of 8 to F. And I'm pretty sure this is it's basically similar to one of the opcode extensions. If you use E8, I think it's maybe similar to opcode extension 5 or something like that. So technically I could use opcode extensions here, but I know that, for example, I think it's MFENCE may have a fixed ModRM that wouldn't fit into that opcode extension model. So for these ones, I'm going to have to just add another field to the forms for like a fixed ModRM that I'll use if it's set, and if it's not set, then I'll just go to generate the ModRM as I usually do. So we've got LFENCE, SFENCE, and MFENCE to do. So we'll just add those to the assembly first. So we've got LFENCE, SFENCE, and MFENCE. Let's just regenerate those. And then let's just take these to the encoder. I suppose we'll just add them here. And we'll add them to the encoder test as well. So this is going to be 0, NA, 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 NA. And then we need to add them to the forms table. So we'll just add some empty ones for now. So if we do a go test here, this should now fail on matching a form. And the form here for all of them is width 0, op_n is ZO, and then the opcode. So we actually have For LFENCE, I think they're all the same apart from maybe the fixed ModRM, but we'll go and look at them. So we've got the secondary opcode map. So this is map 0F. Opcode is AE. And then we need some other field here, which we'll call ModRM, which we'll set to just the one that's in the manual here, so E8. If we go and have a look at SFENCE as well, this one, yeah, so this is the same, but the ModRM is different. So for SFENCE, it's actually F8. And then for MFENCE, if I can find it here, it's F0. So we'll change this one to F0. And on the form, we'll add a new ModRM byte. So if I run this right now, this should fail because we're not outputting the fixed ModRM because they are encoded as having 0 operands. So let's just go to has ModRM check. So here, I think what we can do is basically say switch on, we'll say switch on if form ModRM is not 0. So if this is not 0, then this is what we'll prioritize. Otherwise, we'll do the other thing. So in this case, basically all we want to do is do e.code equals append e.code and then output form.modrm. So that takes care of the memory fence instructions. Next, we'll move on to pause. So let's go and find pause here. Pause is very easy. We've got a mandatory prefix of F3, and then we've got the opcode of 90. So let's just go and add this. This is pause. And then I suppose while I'm here, just to get some more out the way without switching back and forth all the time. So this is F3 90. We'll also do the prefetch ones here as well. So we've got prefetch here. So prefetch, we've got the same thing for all of these, but different opcode extensions. So we've got prefetch T0, T1, T2. So T0, 1, and 2. Then we've got NTA, prefetch NTA. Then here we've got prefetch IT0 and IT1. So all of these are 0F, so secondary opcode map, followed by 18, followed by some extension. So in this case, it's 123076. 123076. Okay, let's just go and I suppose yeah, I may as well just get the last few instructions I was going to do if I'm noting these down like this. So the last ones were basically going to be flush and FLUSHOPT and then CLWB. So we'll take CLFLUSH here, and this just takes a memory operand. So this one is 0F. Then we've got AE, but with this time an opcode extension of 7. This one is the same, but with a mandatory prefix of 66. And this NFX here, this is the same as the NP notation, meaning no prefix, but this is specifically saying no F prefix. So I think it's you can't have F2 or F3 before it. Other than that, though, it's basically just 66 followed by this, but with the opcode extension 7. And then the last one is CLWB, which is the same as the opt one, but with opcode extension 6. So CLWB. Okay, let's just take all of these into the encoder first. Well, let's go to the encoder test first, maybe. So we'll put these down here, and then go and get all of the opcodes, or the mnemonics, I should say. Okay, let's take these into here. We've got MFENCE and stuff. We'll put them below here. Give them some empty forms. Separate them out a little bit. Okay, so let's write these tests. So most of these are going to be bytes with CX as a memory access. But this top one is going to be 0 with NA, no operands here. And these ones here are also no operand. Oh, no, these ones are actually, I've just forgotten to put in the test properly. So prefetch, where is prefetch? Here's prefetch. So prefetch also needs a memory address for the tests. So let's just go and add the same thing. We'll do RCX here. Okay, so we've got 0 with no operands, and then we've got bytes with CX memory access here. Let's regenerate the listing. That's all okay. And then let's take these comments over to the forms. So the forms should fail. Yep. Let's just keep this here. Okay, so for pause, we want to basically match on a width of 0. Op n here is ZO, and then the opcode, the prefix actually, for the first thing, is F3, and then the opcode is 90. Then these prefetch ones are all actually the same, but they have a different opcode extension. So we'll just take the opcode extension down. So these ones are all going to match on width of bytes. They all have op n, in this case, is just M, where op1 can only be memory. Then we've got map, which is map 0f. Then we've got the opcode, which is 18. And then we've got the opcode extension, where we just need that correct number on the end. So that's those ones done. Then CLFLUSH is basically the same sort of thing. So I'll just do these two first. So we've got width of, in fact, actually, I'll just copy this one. Width of byte, op n is M, op1 is memory. Map here is 0f, but before that we have a prefix on this one of 66. Then the opcode is AE, and the opcode extension here is 6. So let's just copy this one is 7, and then this one is also 7, but there's no prefix. I need to add another layer into these expressions here. Okay, all right, so that's all passing. Just a few more simple instructions out the way.